in the in his photographs, and it established the presence of water ice on the moon surface. But on 28 October 2009, communication with the spacecraft was suddenly lost. But although the mission was less than 10 months in duration and it has intended to cover the 2 years in length, a review of scientists found that the mission was very much successful because it is comprised of 95% of its primary objectives. The probe but still the probe was operated for 312 days. So the mission was very much successful. The result was that it has covered the lunar poles and additional lunar regions of interest. Also found the lunar water discovery. This is the main thing what the Chandrayaan-1 has done for our Indian scientist community. On September 2009, it was reported that NASA instrument Moon Meteorology M3, which is also in payloads of the Chandrayaan. But same on the other hand, same on 26th September 2009, the moon has a water ice on the surface. And moon are all developed, not from any foreign countries. The spacecraft Center in Andhra Pradesh on 22nd of July 2019 by Jecrc Mark III, and this is a very much advanced launching vehicle they are using. The spacecraft reached the moon orbit on 20 August 2019 and became orbital positioning for the landing of the Vikram Lander. The lander and rover were scheduled to land on the near side of the moon in the south polar region. They are considered the south pole, not any other pole. That I will discuss in later in slide. On 6th September 2000, but conduct the scientific experiment for the lunar day. This is our geosynchronized satellite launch vehicle Mark III, and it has, you can see that it has many components, and Jecrc launch is designed in a 3-stage vehicle with India's most powerful launching to date, and its height is approximately 43.43 meter, and the lift of mass is approximately lift of 640 tons. So this is the Chandrayaan-2 achievements. High missions represent a significant technology leap compared to previous mission of ISRO, that is Chandrayaan-1. It has the orbiter lander rover for exploring the unexplored south pole of the moon through detailed study of topology, mineral identification, and surface chemical composition, thermophysical characteristics of the topsoil, leading to a new understanding and original evolution of moon. These are the main objectives for the next exploration. So before Chandrayaan and Chandrayaan-2, we are also very much tribute to that is tribute for the Chandrayaan. Actually, that is the before the Chandrayaan-2 and Chandrayaan-1, we have some pole-to-pole distance, pole-to-pole concept also there. That is the exploration of the Earth's south pole in 1909. So now the 2009, the compared exploration is the south, it is the Earth's pole. But in 2019, it is journey is approximately 10 months, whereas the duration of the journey for the moon mission is 9 days, the mission is 14 days. So we can also think about that before the 2019, in 1909, also scientists are thinking about the exploration of the south. The lunar pole is that Chandrayaan-2 and Chandrayaan, that is they have not reached their interior position. So craters are the core trap that contain the fossil records of hydrogen, water, south pole, north pole region, the south pole. For the following characteristics, it has a weight of approximately 2379 kg, power is 1000 watt. It itself consists of 8 payloads, and it's capable of communicating Indian deep space mission network, which is located at Vailodu as well as Vikram Lander. This is the Vikram Lander, which is weight is approximately 1471 kg and power is 650 watt. The lander name is conceived from the Dr. Vikram Indian space program. It was designed to function on one lunar day, which is equivalent to 14 Earth days. It itself has the 4 payloads. This is the pregnant rover, and with it has 6 wheeled robotic vehicles, and its weight is approximately 27 kg. It itself consists of 2 payloads. Chandrayaan 1, Chandrayaan 2. On 22nd of July 2019, it successfully launched, and 24th of July, the first launched successfully, and again on August 2019. See how that how it increases the orbit raising by increasing the velocity of the satellite. In August 2019, ISRO realized that first moon image captured by Chandrayaan 2. This is a very much appreciated. On September 4, 2019, Chandrayaan 2 second deorbiting maneuver. That means now Chandrayaan is surface to moon close to stars. If descent, ISRO loses communication during the fine vacations, and this is the problem that everyone knows occurs due to some software glitches. So this is the final results of the Chandrayaan 2. Supposed to perform soft landing, but unfortunately they are not confirmed that it may be somehow away from the intended trajectory, approximately at 2.1 km altitude, and it loses communications. So what did we go wrong with the wrong? The Vikram Lander followed the plan, but approximately 35 km to just below 2 km above the surface. During the second phase of descent, that is second phase of deceleration, the reduction in velocity was more software glitch that happened with Chandrayaan 2. Due to this, the mission was not 100% successful. As a result, Vikram has landed within 500 meters, had hard landed, not so hard landed. Slide. But this Chandrayaan 2 mission makes the India the fourth nation on the moon after USA, China and Russia. So it has a very much appreciated for the space scientists that we are in the fourth country. Chandrayaan 2 also found that the water molecules on the Chandrayaan surface, moon surface. These are the also it found that NASA Apollo landing sites. These are the all photographs taken by the Chandrayaan 2. These are the pictures also taken by the orbiters of Chandrayaan 2. Between the Chandrayaan 1 and Chandrayaan 2. There is a lots of difference in the Chandrayaan 1 and Chandrayaan 2, but the main thing is that the launching vehicles, which is very much advanced in the Chandrayaan 2, so that it can capable of to launch a net weight of 3,290 kg. That is the very big difference between the two missions. And also it has 13 Indian and 11 from the NASA payloads. Whereas in Chandrayaan 1 is all like 11 built in Asia, USA and UK, Germany. These are all the details that I am shared with you. Now, please, thank you to all. Any questions? Any questions?
I ask questions, we will not be able to
Which question, sir?
Why it failed? I'll give you the reason.
Yes, sir.
Why it failed was.
Sir, let me introduce you first. Sir,
Why it failed, sir?
we were talking about, sir, he is from ISRO.
Okay.
And sir has prepared satellites. So he is
Okay,
from
I
Lander.
have a son of Chandrayaan 1, Chandrayaan 2. When Vikram Lander, which was to do a soft landing, what happens is there are 4 thrusters which were put, which had a overall 4 side thrusters and 1 main thruster. So what happens is the main thruster was put as a afterthought, so that when the satellite was to move in a particular orientation, it may not get the same thrust. So at 2.5 and 2.1 or 2.5 kilometers, before that, the 41 degrees orientation was to be made. Instead of 41 degrees, all the 4 thrusters plus the main thruster fired. There was a unequal force being generated. The total overall force for retarding this particular from 6,000 kilometers per hour to 2.1 kilometers per hour. So what happens is, due to the uneven, once it trembled, due to the unequal, because 800 Newton's force is coming on those things, it trembled. It went to 100. So once it goes to 180 degrees, it just turned around. So instead of reducing the speed, it increased 10 times, and it crashed on the land. This was the because correction of putting a main onto the rocket was on the this Vikram was a afterthought of that, which is not acceptable. There was a lot of discussion that we should have put 1. Yes, had we put 1 with the other things coming, changed. So this was one of the biggest failures. So 2.5 meters, it just trembled, and the speed went to almost 10 to 100 times more, and it crashed on the land. So this was the unfortunate thing which happened. Why things at the last moment on all the 4 thrusters was even but why again the nozzle was not working properly, or it did something. So because of that uneven force coming on the 4 thruster, rotated the things.
Sir, are you thinking that not more thrusters?
No, there are 2 options which are thrusters. Then you don't have to for tilting, you unevenly distribute the force, it can tilt. And if you are having is the main thruster which is generating, then you will have to use that also. Both ways there are pros and cons. You will have to optimize in which way particular thing the analysis has to be.
So that analysis will be more precise.
No, it has to be sometimes some components. Itself had has been a single point failure. It should not have created any problem. But in this particular thing, because of the crumbling of that, because one thruster was firing at a low value, others were firing equally, it crumbled and reversed in the way. So instead of decreasing the speed to 0, it increased almost 10 times.
That's why they are calling the hard landing.
It's not a hard landing, it's crashing. There is nothing called a hard landing. It was a fault which has happened. So this was all the Chandrayaan 1. I was associate program director for the full mission. All the payloads. In fact, some of those things I intend to start over here, but I will not reveal my card for the present. I have is already planned. That I worked out things where I intend to take a few students and faculty where we can design these type of things. And I intend to, I think this November, and we'll have this exhibition over here. I'm revealing that also for the first time, and we will have and many other things on. Good presentation.
Thank you, sir. The questionnaire will be at the end.
Thank you, sir, for enlightening us with Chandrayaan mission. We are running short of time, so we'll take the question answers later. Now, may I invite our guest esteemed speaker, Dr. A.K. Bandyopadhyay, sir.
Hello. So it is still morning. So good morning, everyone. Pranav sir, ma'am, and all the sirs to allow us to interact with the students, because we are from Pilani, as you have already seen. So many students we are not getting every day. So very heartening to see that all of you are full of energy and attending this. So today I will be talking about 5G technologies. So earlier I started work in microwaves, in high power microwaves, but recently I have shifted to this domain. So basically what I will be telling is the information which I have learned, say, in the past 1 or 2 years. Okay. So first, the outline of the presentation will be. Okay. So the first thing is, I am audible now? Yes. Okay. So this is the outline. So before going into the detail, just let us ask ourselves that all of us are students of, say, research and technology and science. Okay. Now, what is the purpose of technology? If we ask ourselves that what is the purpose of technology, so the purpose of technology is to make the life easier. Make the life easier means make the environment more good and
improve the quality of life. Okay, so this is the sole goal of the technology, and if we see that this includes that work, family, friends, health, life, and also the environment. Okay, so together with the environment, if we want to increase the quality of life, so that is the purpose of the technology. Now we will see that when we call about the technologies, when we call about the advancement of the technology, we will see that technologies always has lifted with some revolutions. Okay, the first revolution, industrial revolution, okay, so this is the mechanization and steam and water power. Then came the mass production and electricity. And then came the third revolution with the electronic and IT systems and automation. And currently now what we are seeing, that we are in the revolution phase, that is for the cyber physical system and the digital era. Now the thing is that the past 100 years, if we see that these took too many times, but the digital revolution, it is coming too fast. Okay? So if I recall, when I was a student like you, I have never imagined that there will be a phone like a mobile phone, and that will be so powerful that it will be able to communicate with anyone in the world within no time. Okay? But it is a reality today. Alright? But now, if we see that in order to do that, and if we see where we will have to go, so it is something like this. This is a data that I have taken from the Ericsson Mobility Report, that is a global company for digital mobility. So here we are the data used per mobile phone in many of the countries. Okay, we are in the say India. 2020 we are somewhere here around 15 GB per data, 15 GB per mobile per month we are using. But if we see that the way the data is increasing, 27, it will be around 15% increase, and it will be around 50 GB of data. Now, not only the mobile phone, the data you are using also in the home and all this. So this means that okay. The same thing. So here we are around 50 exabytes. So 1 exabyte means around 10 to the power 9 gigabytes. Okay. So in the global scenario, you will see that the projected data, it will be, maybe it is going to around 20 times or 20 times of the data that we are currently using. Now the network or the systems that we are using, so those systems are having two parts. One is the network itself, that is the core network with the fiber and all the things. And there is another part which is called radio. This is where the core network is from the fiber. You have the data in your wireless device. Okay. So that is the radio part. Now to have that, we will have to manage this huge amount of data inflow or data outflow. We will have to plan the system accordingly. Okay. So now, if we see how the generation of the mobile, the G comes for generations, alright? So if we see that how the generations came, so if we see that the first generation, it is just the analog device. So in the 2G, that is the basic phone where we could have only the voice, and then in the 3G, there's a feature phone and some slow speed data and email. In the 4G, the smartphone with high speed internet, and in 5G, it is evolutionary and revolutionary services connecting many devices together. If you see, there are many devices which are connected together. So, and now if we see the numbers, so for example, if we see the numbers, here we will see how the data rate, that is how fast that how the data is being increased from first generation to fifth generation. So from 2.4 kbps in 5G, we are expecting around 1 to 10 Gbps. And the frequencies which will be used for that is 2 to 6 gigahertz, and the suitable band is 30 to 300 gigahertz. And the data will be voice, data and video. What type of data we are expecting, that will be seeing afterwards. So, what are the difference between the earlier generation about 5G? The earlier generation of the data of the mobile phones or the network, it is just the upgradation of the network itself, that whatever available technologies were there, we were using to increase the speed of the network or to increase the connectivity of the network. Okay? But now with 5G, we have to connect seamlessly to all the or the cars or wherever you are. Say even if you are in a high-speed train or in say buses or say inside. So the idea is to connect everything seamlessly. And also there will be also the devices like inverter. So it is not only a, you know, the roads, it can connect to the many facilities like, so it is something like that. For each connectivity, the framework option of connectivity for different devices and different services will be there, so that we can have a seamless integration of the services. Alright? Now, let us see, to do that, for example, if you are say in country A and in country B. Now if you want to interconnect to the railways, so what you will have to do? You will have to make sure that the tracks, dimensions of the tracks matches. Otherwise, the train will not go from one part to another part, so there will be a stoppage. So now if you have, you will have to fix some standards. Okay, these are the parameters. So for example, say if you are designing an antenna, if you are designing an amplifier, if you are designing anything, so you will have to first standardize, or you will have to first fix that what are the parameters that must be uniformly told to every country, so that similar okay. So this is called standardization. So this is somehow we are not very aware of the standard. Standardization came, say, but now this standardization procedure, it became very global, and it is a global affair of each of the countries. Okay? So the benefits of standardization is it maximizes the compatibility, so that global excellence also can be achieved, and then safety, repeatability and quality, all these things can be achieved. So for the previous generations, what happened? For the previous generations, the networks was evolved with the things that were available. For example, if there was an increased speed in the say data rate or in the antenna, that was put into the phones or into the network, so that whatever is being available, that was put to increase the efficiency of the network. But now people have thought that now let us not go into that way. We go, then we draw down the parameters, and then we standardize this, and then we evolve. I was telling. So now in order to have those standardization means, for example, now if you want to make something for the 5G, you must know what you will have to make, what you will make. So now who will tell you what are the standards? International Telecommunication Union, ITU, that makes the standard. So there is one body under that, that is ITU-R. Okay. So ITU-R is the for radio communication. So actually, sir knows very well, I think, that whenever we are launching any satellites or anything, so there are lots of negotiations for the correct band and all these things. You are who uses or who harmonizes all these allocations and all. Yes, yes, yes. And it is a lengthy procedure. And body, this ITR, after deliberating with all the nations and all the parties, so they have features that what should be the features of the upcoming 5G network. Okay. So these are ultra low latency. What is latency? Anyone? Latency? Time lagging. Okay. The time taken whenever you are asking for an information and lag between that time. Okay. So there should be ultra low latency, high reliability, advanced antenna technology, millimeter wave technology, massive IoT, Internet of Things, and spectrum flexibility. All these things were identified by ITU. Now, these recommendations were given to the bodies. Bodies means there are 7 countries, 7 bodies. The ETSI is the European Telecommunication body. TSDSI is for India. ARIB is from Japan. ATIS is from USA. CCSA from China. TTA from Korea, and TTC from Japan. So this body, all these organizations, they have created one group or one consortium, which is called 3GPP, Third Generation Partnership Project. So with that organization sit together and fix all the requirements. For example, in India, say one of the requirement was the mobility. While having the mobility connectivity with the mobility, the other countries were very comfortable with high-speed mobility. But for India, it was not so high speed. So there should be a case for lower speed mobility. LMLC, low mobility, large cell. So that requirement was put together, put by India through TSDSI. And so what I was trying to say is, whenever you have a particular case in mind or our requirement, we will have to create the requirements for that and put to the ITU through this body, through TSDSI in our case, and then our case will be also put in the standards. That is included in the standards. Now, what are the use cases? Means these requirements, for defining the standards. What are the use cases or what are the types? So actually, the types was what it means. Now we are trying to categorize the application. So there will be some cases. For example, when you are in a smart city application, so what will happen? You need to monitor the environment. So how will we monitor the environment? We will put many sensor nodes which will register the temperature, the pressure, the parameters of the water, the amount of say NOx or CO2. So these things, and we cannot place that only one only one node and tell okay this is the parameter for the whole city. So you will have to put the millions of these sensors across the city, which will be transmitting the data. So here the requirement is the data which will be sending by each sensor is not huge. That will be maybe 1 or 2 say lines. So it doesn't take much bandwidth. But the catch here is it would be important for this case. So so where these things are important, so smart city, smart agriculture, smart home or smart industry. Okay. So here the requirement is not of high bandwidth, but the requirement is for large capacity. Next, say the enhanced mobile broadband. So here, for example, when we were in the time of Corona, say, at that time the entire education system was on via the digital medium. But there, to have a more or less good interaction with the students, so you would have a video connection. That would require large bandwidth. So there, maybe the number is not in billions, but still the number is also important as well as the bandwidth is important. Okay. So this is another use case, and there you can also add the augmented reality or virtual reality. Okay. For gaming also, distributed gaming, now I think you also are habituated or know the distant gaming, means you can game with a partner which is not with you but distantly located, but those things require very high bandwidth. Okay. So this is one another use case. Okay. Then there is ultra reliable and low latency. This means that here the catch is the reliability and latency. For example, where you will have to take decision in very split seconds. For example, if you are driving a car, the autonomously driven car. So there, if you have delay in the network, that can cause an accident. Similarly, if there is a case of remote surgery, for example, if some patient is in a very difficult terrain where the doctor physically cannot reach, so he can have a online video type of thing, and through haptic control he can perform the surgery. But that will require a very reliable and very low latency network. Okay? So that is another requirement. Okay? So the cases under this is remote surgery, remote driving, remote robotic motion controls, online gaming, real time. So in this way, around 74 representative services were registered from each of the countries that I have told, that the 7 countries who are making the standards. Okay? From each of the 70 countries, the requirements were fixed and then the types were derived, and the resultant was such a diagram where you must have seen this diagram if you have researched a little bit about 5G. So here you see that there are the three tips of this triangle, if you call it a triangle. The one is the enhanced mobile broadband, one is U1 LLC, that is the ultra reliable low latency communication, and another is massive machine type communication. Okay. So these are the 3 things, and some of the applications will have everything in common. So you see the requirement where enhanced mobile broadband is needed, they don't need say that much of latency. Means, or when MMTC is needed, they don't need so much of reliability. Okay, but there are some applications which need all of these things. Okay, so in essence, what I am saying is, it is not that you will have to design a network which can serve all of these on a demand basis. Means who is demanding broadband, you will have to be able to serve him broadband. Who is demanding ultra low latency, your network will have to be able to provide him the latency. Who is demanding both, your network will have to serve him both the things. Okay. So therefore,
defense is kept out of
defense is totally different. So this is the getting from these discussions or this thing, that your network will have to serve what the customer or what the will be user wants from your network. Okay. Now, if we just go for some use cases, so for the first use case, for example, so this is a unmanned air vehicle use cases. So here, this is the security and surveillance. This is, of course, this is not the security or surveillance for the military. This is for the inland security, means for the police affairs. The surveillance, security, e-commerce, entertainment, etc. So here the use case will be the drones. So here you see that there is an ensemble of the drones which are flying in a particular while flying. Now this can only be possible when there is a coordination between the drones and the server and between the drones. Okay? So otherwise this type of constellation will not happen. But here if you see the number of drones, maybe some hundreds or maybe some thousands of drones can be used. Okay? But here this is a use case of say ultra low latency as well as capacity, means massive, means numbers. Here latency is also important and also numbers are important. But broadband is not that much required because they are only for showing purpose. But if those drones are there for putting surveillance video or transferring surveillance video, then all the three components you need. So you will be in the middle of these three. Okay. Maybe you don't hear it. Alright? So and okay, so this is one use case. Second use case if we see is the robots and cobots. So if you see a automated industry, here what we see, we are having that robotic arms which are making cars. Okay? But now these robotic arms are also moving and they exactly know when the next piece of item is coming to it. And they also have to know what is the position of the arm of the earlier robot. So they need to communicate with each other as well as they need to communicate with the controller. Okay? So here also you see that latency is important and the number is important. But they don't need to transmit video to each other because the robots, they don't need the videos. They only need command and the coordinates. Okay. So here also massive machine type IoT is needed. Okay. So here is another thing. This is called cobot. So research for big research. Okay. This is one use case of artificial intelligence. The artificial intelligence where it will be needed. And here are this is a I think it is Dynamics and Boston Dynamics company. If website you can find many interesting robots from this company. That is Boston Dynamics. Okay. So here you can see this dog or this robot dog can go and it can have video. It can do small shopping and you can program it. Okay. So for this also you need some type of, you don't need the number, but you need, if it transmits the video data, you will need a broadband connection as well as low latency. Okay? And these are the some robots which are being used for e-commerce purpose. Next use case, this is called the connected car. So here, in order to have safe driving or autonomous driving. Okay. So here for some cases the broadband service is also required. Okay. And these are for the whenever we are say in high speed mobility mobile conditions. For example, when you are traveling in the train or when you are traveling in the plane, then most of the time we get bored. So we need to watch some movie maybe or having some calls. But that thing actually takes lots of bandwidth. And high speed mobility is always a problem for the service provider because you are not having any base station. But that is the most wanted thing. Means people want or people can spend money for that because so I can recharge say maybe 400 rupees. So for commercial people, these scenarios are very attractive. But to put the service there is more difficult. Okay? So this is another, and also for the smart city. The smart cities are planned or being installed since a long time. So here in the smart city, what happens? There will be environmental monitoring, there will be autonomous and connected vehicles and signaling. There will be e-commerce and electronic health and education. So another thing, that aspect that I forgot to mention is about the security. Means whenever you are transmitting lots of data in the air, so always the question of security comes into your mind. Means monetary transactions also will. So here the blockchain type of thing, blockchain type of technology where you cannot tamper the sequence of the events. So that thing is also important, right? So now these are the things that we have learned, that these are needed and this is needed for that. Now if we look at network, how it would look like with all these components. So this will be looking something like that. This will not be a uniform type of some base stations will be there and everything is connected by fiber. Type of thing. It will be a highly heterogeneous type of network. Radio networks, radio access AN, radio access network. Okay. Experience is always have this radio access network. Right now, if we see, for example, your is the band that we are using. Anyone? 800, then 2300, 2100. Mobile phone box. This band means 2 to 4 gigahertz. Okay, and also. But the thing is that the frequency spectrum is already that you cannot. You want more speed over till now, like connections which are there in the sub-6. When your road becomes congested for inside a city, so you will also always have to make a bypass. No, so that is why people are trying to, or people are frequencies. Now, to move upwards in the frequencies means what? So what are the other things? What are the other things that we will have to go for upper frequencies? This means millimeter waves. What we will have to then make? That you will have to make, because you will be graduated in a few years. So you will have to do all this. You will have to design the antennas, which are use of dense cells, resource constrained edge computations, network slicing, ultra high data rate radio. Okay, all the things I will try to explain a little bit. Okay, what is the MIMO? MIMO is multiple in, multiple out. Okay, this is very easy. Now what happens that if you antenna, the things are very simple. You are sending data from here, you are receiving from there. But the thing is that you will have a limited data rate. But if you have multiple sending antennas, multiple receiving antennas, you can send higher data, because each of the antennas you can send different type of data sets. But the problem is, in the receiving side, other than the intended signal, you will also get the signals from the others. So that is the catch of the MIMO antennas. There are different type of MIMO antennas, single user MIMO, multiple user MIMO. Okay. So there you will have to take, or you will have to design those things properly. Alright. Also, there is one possibility of beam beam forming. This means that you can have a antenna which is forming beam to other users, and one user gets one beam. So that also can increase your data rate. Okay. So okay. Also, you need to design of the normal antenna and MIMO antenna a little bit different. So here you will have to do the electromagnetic simulation as well as ray tracing simulation to see the. And also there is a possibility to increase the capacity. Like if you have the wider cells before, you can go for denser cells so that your coverage and data rate increases. Okay? And as I told in the beginning, that there should be a network for each of the part. So whoever preventing broadbanding, you need to give broadbands for that. Okay. So network slicing is another one, and edge computation, where you can have smarter nodes where you don't need to compute much in the beginning. In the cloud, you can have the computation in the camera. Okay. So, okay, I will just tell about this slide. So this is the different layers that is being planned in 5G. So one is the coverage layer, one is the capacity layer, and one is the high throughput layer. So when I told millimeter wave, it is not that everything will be done in millimeter wave. So it is different part for different applications. So just one or two things for what is coming next. So till now we are having the videographic information, but now in the next time, in the 6G, beyond videographic communication, so that means that you are about to see. Okay, but that will also need say 30 times or more bandwidth than that. So that time we will have to go for millimeter wave to terahertz. Okay. Okay. So and also there will be tremendous applications of the AI. So this is, have you seen this movie? So this is a still from the iRobot. Okay. So if you see all the robots, there is a difference. Can you find out which is the difference? Yes, this robot is not following the program. So when AI, that is artificial intelligence, maybe it can evolve by itself to something else. But this day is not far beyond AI. Okay, this day will come maybe in 4 or 5 years. Okay? These are all that 5G deployment aims to enable seamless integration of several technologies, as I told, and several technological aspects are being pursued globally for 5G, like frequency allocation, network topology and management, millimeter wave technology, etc. And the technological evolution of 5G is to be continued, so it will be towards. Thank you.
Just want to ask this. When you are migrating from an 4G to 5G system, one is network and one is smartphone. Smartphone also have to change.
Yes, sure.
Overall,
Actually, for the time being, the 5G which are being launched, they are in the sub. There will be not very big change in the smartphone for the time being. The entire reception will be based on the terahertz or millimeter wave antennas.
no, even if it is a small change, like 1 bit or another 2 bit and a change or ABC you have changed to some other
Yes.
value. And then the whole system and now
That
the
has
whole
to be changed.
system and now
Yes.
is thrown and then new one
Yes.
has to be done.
So, sir, there are now the companies like the what? No, not Nokia. chips making company? Snapdragon. Snapdragon and all these things, they are now making these 5G compatible chips. So that those chips will be replacing the chips of the mobile phone.
So all junk what we have collected is wrong.
Unfortunately, yes. But this will be taking maybe 3-4 years time. So just like the earlier mobile phones.
Like what Reliance, they say that by Diwali they will give you 5G. Then what?
Sir,
how do I use it?
That is
If
now, as of now, sir, in India, the 5G services have not begun. So it is just, if you see closely, it is written that it is 5G ready. So and frankly, sir, if you take 5G right at the beginning, there will be no much big difference. There will be a big difference, maybe after 1 year or 2 years, but now I don't think there will be very big difference. Yes.
Yeah, I have one question.
Yeah, please. Please.
How much this 5G is, it will be affected by the solar storm?
Actually, the millimeter wave part, now till now, mostly based on S-band for the mobile phone, for the television and all. Millimeter wave link is very difficult because I skip those sites because millimeter wave is very much affected to the environment. That will definitely be affected, but that's why the people are saying that they will make the cellular phone cells, those more dense, so that maybe one cell only covers say few hundred meters, not more than this. So that is what is proposed right now.
Sir is also working on that. But they are that
You want to ask your query. To felicitate our Thank you, sir. Now I request Professor D.P. Mishra, sir, to felicitate our honorable guest, Dr. Amitabh Rao Chaudhary, sir. Thank you, sir. I invite Professor Renu Sharma ma'am to give a vote of thanks.
रेणु शर्मा यहाँ विराजमान अतिथि गणों को अंतर्मन से आभार व्यक्त करती हूँ। धन्यवाद सभी को, बच्चों को भी। मैं प्रोफेसर प्रेसिडेंट सर, प्रो प्रेसिडेंट सर, डॉक्टर रामरतन सर sir, senior advisor sir, and emerging scientist also, registrar sir, Dr. S.L. Agrawal sir, Professor sir, Professor Vidhi Dubey ma'am, Dean Science, Professor R.A. Jain sir, COE Examination Cell, सभी ने आकर यहाँ अमूल्य समय दिया है हमें, हम इसके लिए आभार व्यक्त करते हैं। मैं डॉक्टर बंदोपाध्याय सर और अमिताभ सर का आभार व्यक्त करती हूँ। उन्होंने हमारी यूनिवर्सिटी JCRC यूनिवर्सिटी के लिए अपना टाइम निकाला और हमें हमारे आमंत्रण को स्वीकार किया, उसके लिए मैं तहे दिल से धन्यवाद करती हूँ सर। मैं आभार व्यक्त करती हूँ फिजिक्स डिपार्टमेंट HOD सर डॉक्टर प्रणव सक्सेना सर का, पूरे फिजिक्स डिपार्टमेंट का जिन्होंने सहयोग दिया, हमारी टीम का, ऑर्गेनाइजिंग सेक्रेटरीज का, अभिषेक सर, चंदन सर, सप्ती मैम, हरिओम सर, शिवानी मैम, निशांत सर, सभी का मैं आभार व्यक्त करती हूँ। और मैं तहे दिल से आभार, अभिनंदन और धन्यवाद सभी बच्चों का करती हूँ जिन्होंने इस सेमिनार को सक्सेस या सफल बनाने में अपना संपूर्ण योगदान दिया है। क्लैप फॉर थैंक यू सो मच। धन्यवाद।